Stop. That's how you were able to see us in Japan. Okay, everyone. So let's assume 1n is k, right? You've done 1 and 2, so Pn is the statements, okay? Pn is the statement. 3 times 5, 2n plus 1, 2, 3n plus 1 is divisible by 17. So that would be 17m, kind of. Okay? So we're going to assume 1n is k. Assume Pn is true for n equals k, right? That's an inductive hypothesis, which means 3 times 5, 2k plus 1, 2, 3k plus 1 is 17t, where t is some integer, right? That's an inductive hypothesis. So we don't know how this will be. We don't know if it is going to be useful. Well, we expect it to be useful. So when n is k plus 1, let's see if we can make sense of that. When n is k plus 1, we're going to be having 3 times 5, 2, k plus 1, plus 1, 2, 3, k plus 1, plus 1. Yes? Okay, so this is definitely 3 times 5, 2k plus 3. Is that 2k plus 3? And this is 2, 3k plus 4. Yes? Okay, so we need to see how we can make that look like 17. The problem I'm seeing here is there are 2 exponents. If it was only one exponent, it would be a very simple case, right? Is that why most of you were confused? Okay, let's see what we can do. So, this looks more complicated. So, I'm going to assume we suggest we make this the subject. Hopefully that works for us. If we make the subject from here, 3 times 5, 2k plus 1 will be 17 minus 2 to power 3k plus 1. Yes? Is that what you did? Anyone? Okay. So let's see how we can bring that here. Now this is 2k plus 1, but this is 2k plus 3. So we need to take what out? What? 5 to power 2. Do you understand? So this is going to be 3 times 5, 2k plus 1 times 5 to power 2. You agree? And this is going to be 3k plus 4. So now this can be substituted. Let's see if that works. So 17 minus 2, 3k plus 1 times 25.
Forgot to write the T.
Oh. Yes? Times 25. Do you know how I got times 25? 5 squared. And this is 3k times, that's 16. I don't think that's necessary. We leave it for now. Okay? I'm also looking at something. Actually, this is 2k plus 1, right? How about we make this also plus 1? If we make it plus 1, then we multiply by what? 2 to power what? 3. Okay. I think it will work. Well, this is why I thought of that. I know this will probably be some variable. Let's assume this is some variable y. I'm trying to make sure I get y somewhere there. Because when I open this bracket, this will be 25y. If I have something like, okay, let's open the bracket. 25 times 17t. Agree? Please pay attention. Yes? This is 20 minus 25 times, I put it in brackets, 3k plus 1. Yes? Is that? So now this looks like, what is 25 times 17? Quickly. Oh, you don't even need to actually do that. Let's leave it as 25 times 17. There's a reason. Then the other one, I look at it as 25y. Okay? I'm trying to make sure this also contains y. Some maybe my, where m is a number. To be able to get this, I try to break this so that I can get this out. I need 2k plus 1. I need 2 raised to power 3k plus 1. But I have 2 raised to power 3k plus 4. I need something common. Okay? So that's why I broke it down into this and this, just like we did before. We have done it before in the case of 5. Hello, am I confusing? Raise your hand if you understand what I'm saying. Okay. How about you?
I don't understand that.
Okay. Now, let's start from here. This is when n is k plus 1. This is what we have. We've said before, we are used to making one the subject, right? But this is different because there are 2 exponents.
Oh, so you need to switch it around.
Not really. There are 2 exponents. That's the confusing part. If this was just a number like we have done before, it won't be an issue. Okay? So I'm thinking, this looks more complicated than this one. So let's make the more complicated one the subject, so that we can work with the less complicated one, even though there's still complication here. We don't know out there where that might lead us, but let's just try. So we came up with this. Okay? Now, in the case of this, what we are trying to substitute is 5 to the power 2k plus 1. But what we are trying to prove contains 2k plus 3. Yes? From here. This is what we are trying to prove. Open the bracket, 2k plus 2 plus 1. That's 2k plus 3. Also open this bracket, 3k plus 3 plus 1. That's 3k plus 4. So the power of 5 contains 2k plus 3. But the power of, now this is 3. Looks like this. This is 5. Looks like this. The only problem is the power.
Yeah,
So in order to make it look the same, we remove 2 from this. That's why we said 5 squared. That's this one.
Yeah, no,
So the combination, hold on, the combination of this and this give you back this. Does that make sense? So the reason we separate them is because of what we want to substitute. We are substituting 3 times 5 to the power 2k plus 1. But what we have here is 3 times 5 to the power 2k plus 3. So to make it look like that, we separate them into this and what makes it complete. Do you understand that? Do you understand? Okay. So now, this part now is exactly this. Okay? But this alone does not equal to this without the 5 squared. That's why there is 25 outside the bracket. But then we still don't know what to do with this. Okay? Now, as I was about to open the bracket, I noticed that this will eventually become 17t times 25. Then 2 raised to the power 3k plus 1 times 25. Maybe if I have something like this also there, then I can do the addition easily. What I mean is this. This has 2 raised to the power 3k plus 4. Now, during substitution, this is going to be left with 2 raised to the power 3k plus 1. But if I can have the same 2 raised to the power 2k plus 1, then when I open the bracket, some terms can hide. So it can look like this. If I have 25 times z, which is the first one, then 25 times y. Y is this. Okay? If I can make this to look like maybe plus 10y, then you know these two can be combined to form a single term. Do you understand? But I must have the same y to try this. How do I get the same y? I must get the same thing. Look at it. This times 25, so that is this. So this is the y that I'm talking about. Does that make sense? Brandy? So I'm trying to make sure the next term is in form of this also. But what I have is this. That is why I broke it down again. So that my next term will be what? Plus, yes? Talk to me, it's louder. 8 2, 3k plus 1. Can you see that?
Oh, I see what.
Can you see now? And you should be able to see the reason why this is necessary now.
I thought the first part was already like that. So.
Okay, but is it clear now? So now, the combination of these two gives what? Negative 17, which is what I'm talking about here. So this happens to be 8. So while this is 25 times 17t, this is negative 17y. Do you agree? That y is the 2 power of 2. Okay? So when we simplify 25 times 17t, negative 17 to 3k plus 1. I think you can see your result clearly. What is the objective? Can you see why it is divisible by 17?
Yes.
What do we do to make sure it is divisible by 17? What? Factorize. You make sure you can 17 bracket something, which is possible here. That's why I said do not multiply this. Remember, initially I said give me the product, right? Then I said don't bother. Because I can see part of my problem is solved. I just need to make sure 17 is out of the other one. Okay? And with this now, 17 brackets, what is the first term in the bracket? 25t. And the second term in the bracket? 2 to power 3k plus 1. And is that bracket an integer? Yes. In that case, the result is proved. So you conclude yourself. Wake that foodie up. Come and have some of the sugar. Come and have some of the food you brought to class.
Yes, please.
So that you wake up from your sleep. Does this make sense? So when you have complicated case, this is the kind of trick you can use. Alright? So take note of that and try this problem too. Five minutes also to make a tent.